Today we are going to go through this lab on Snort and firewall rules. To use the Snort and firewall, we need to install the CyberOps Workstation VM. So I will show you how to install the CyberOps Workstation virtual machine on the Oracle VirtualBox. So I assume you have the Oracle VirtualBox installed. So let's go on to import the virtual machine into Oracle VirtualBox. So the first thing you need to do is go to Machine, New, and then you click to open up this window. So on this window, you give your CyberOps virtual machine a name, and you can leave the rest by default. Okay, ISO leave blank. Windows also leave blank for now, and we click Next. So for the memory, you can leave the default 2 GB, processor 1 CPU, and next. Okay, this you need to change. For virtual hard disk, we need to select the second one, use an existing virtual hard disk file. And after that, we go and click on this to select the virtual hard disk. So on your hard disk selector, you need to click Add, and we will navigate to the folder with the virtual hard disk. In our case, it's on D drive, SOP folder. And we will import this virtual hard disk called CyberOps. And we click Open. So now the virtual hard disk is imported over here, CyberOps, and we click Choose. So just make sure it's the CyberOps virtual hard disk 1, and then we click Next. So finish, the VM will be loaded. So once this is done, we are ready to start loading the to initialize the CyberOps virtual machine. So we'll click Start, and then the virtual machine should run. So it will take a few seconds to start. Okay, so now the CyberOps virtual machine is loaded. So let's try to log into the virtual machine. The credentials for the virtual machine is listed in your lab sheet. Username is analyst. The password is CyberOps. So let's log into the virtual machine. CyberOps. After that, the virtual machine will continue to initialize. Okay, so now we are ready to start the lab sheet. Okay, so before we begin, let me just do a quick explanation of what this lab is about. So for this lab, you will see there are this network over here. Okay, so for this network, what we have is the first group of computers here. The red color box represents the set of network computers inside the company, for example, the office network. And then on the right-hand side, you will see this bunch of routers and computers. So in order for the office network computers to access the internet, they have to pass through this router. So this router, usually we call it the border router, is the router that controls the network to the external internet. And you see over here, so this is the external internet. So from this router, usually it is installed with firewall and intrusion detection system, IDS. Okay, and the network, office network will connect to the internet ISP router, which is this ISP stands for Internet Service Provider. Internet Service Provider. So usually this is your Singtel or StarHub network. So the Singtel or StarHub router will connect you to the internet depending on which service you want to go. For example, you may want to go over to the web page of this company. You can go over to the web server and so on. So together with the other internet services, your computer is also exposed to other malicious computers. For example, there may be a hacker over here. So this hacker is on the internet, then the hacker will try to penetrate your company network on the left to the ISP router and the router in the company. So what happens is, in order for the office network to prevent the attack from the attacker or the hacker, the border router R1 will have to install firewall and intrusion detection system to try to detect the hacker before the hacker can do anything funny. So this is our lab over here. So we are going to create this network on the CyberOps. So let me show you how we can connect. So first thing first, we go over to the lab environment. On the lab sheet, we have done this part already. We have started the virtual machine. So next, we are going to the virtual machine VM, and then we are going to configure the network on the DHCP server. So I'll go over here and start a terminal session. So this is my terminal session here. So for this section, I need to key in this scripts under the script folder. So let me just type in this thing. So type sudo /labs support files scripts, and then configure as dhcp.sh, and then press enter. It will prompt me for password. The password is the same as before, CyberOps. And then it will tell me IP configuration successful. So let's try to verify our IP address using the ifconfig command. So we go over here and we type the ifconfig command. Okay, so now we can see our IP address has been configured. For my internet adapter, I'm configured to 10.0.2.50. So this is the IP address that has been configured for this network. Okay, we are ping Cisco command for now. So let's go over to part 2. So part 2, we will start to investigate the firewall and intrusion detection system, IDS. So some explanation over here. The differences between firewall and intrusion detection system. So both the two firewall and IDS, usually we use it to automatically monitor the network by looking at the incoming traffic and outgoing traffic. So what the firewall will do is, in the firewall, they will have what we call a rule sets to try to check each packet for information. Okay, every IP packet will have what we call a packet header, and the packet header and also the payload will be matched against the rule inside the firewall. So depending on the rules you set, you can actually control the traffic. So some of the rules have different components. For example, you can match every packet with the source address, the destination address, or the protocols and ports and whatever. The other way is we can do what we call action component that match the packet according to the actions that the packet is doing. For example, you want to receive and forward the packet to a particular source or destination, or you may want to drop the packet if it comes from a certain IP address or from a certain port. So these are some of the things that you can do on the firewall. So let's take a look at the CyberOps to try and run this network. So to do that, we will use this command, sudo lab support files scripts CyberOps extend topo no firewall. So let's go over here to run the command sudo /lab support files scripts. Sorry, I can't remember the command. It's Oh, I deleted it accidentally. Sorry. CyberOps extended. Topo no firewall. Okay, so this is the full command. After that, I press enter. And this is a Python script that will automatically create the network that we want to see over here on top. Okay, so this Python script will automatically generate all the virtual servers, routers, and switches, as you can see over here. After it finish, it will be showing this prompt called Mininet. Okay, so let's go over to the lab sheet and see what we need to do. Okay, so we have created the mini network. So let's try to take a look at the R1 router using this command xterm R1. So let's try to type xterm R1, press enter. You will see a window pop up. So this window refers to the R1 router, which we will use later on. So this is the so-called console window connected to the R1 router. Okay, so we'll leave it as it is now. We leave it here. So next, we go over to the R1 shell and start the Snort command. Okay, so inside the R1 shell, okay, this is the R1 shell. Okay, I'm going to type this command dot support file scripts start Snort. Okay, so I'm typing this one dot lab support file scripts starts Snort. Starts. Okay, so this is the command. So after that, I press enter, and it will start or initiate the session for Snort, which is the intrusion detection system. So once the Snort is started, this is what you will see. Okay, you will see some traffic sessions. The timestamp for today, January 11. The time is 6 o'clock 20 minutes. Okay, this is based on US timing. I think it's UTC one. UTC timing. Okay, and of course you have the address that you receive, the IP address, IPv6 address, and also this is the IPv6 mesh packet. Okay, so we'll leave it running at the background. Next, we will go over to do the same thing for H5. Okay, so let's open H5 server. We'll drag this, put it aside, and go over to H5. Xterm H5, press enter. So same thing, H5 will be spawned. We'll leave it one side. and we'll run also for H10. So we'll do the same thing for external H10. Okay. So now I have a couple of terminals in the screen already. So I have H10, I have H5, and also I have R1. For this part, I have started H5 and H10 on the Mininet. Okay. So for H10, what I'm trying to do now is I will launch a web service that is running on H10, and the web service contains a malware. Okay, so web service will contain a malware. So this command which I run is called lab support files scripts mail server start. So once I click and run the program, it will show this. And now this H10 is running a web server, and the web server has a malware. Okay, so it's running already. Okay, it's running. So we leave it as it is. So for H10, okay, we'll run this nested command to try to verify that the web server is running. Okay, so let's try to run the command on nested space EUMGA. Press enter. So now we can see over here, the web server is running. This is the service TCP running on the web server on address 000.port 6666. Okay, this is the local address. On the foreign address is 000.star. That means any traffic can come in. The web server is on the listening sticks on port 874. Is running on the Nginx web server. Okay, so now we confirm the web server is running. So let's go on to the next step on R1. So next on R1, we are going to see the instance R1. So notice that now my R1, if you can see the R1, we will have a couple of packets that are coming in. So we notice that the packet is captured every 2 minutes. Can you see? For example, this one, this packet is captured at 6 o'clock 23 minutes 6 seconds. And this packet is captured at 6 o'clock 25 minutes 49 seconds. So approximately we can see the Snort intrusion detection system is capturing packets every 2 minutes. Okay, 2 minutes interval. So now let's go over to R1. Open another R1 terminal. Okay, so we'll leave this R1 terminal running in the background. So we go and open another one. So let's type external R1 and press enter. So now I have another terminal for R1, which I'm going to use now. So in this R1 terminal, I'm going to type this command tail-m alert. Okay. So let's type this command tail-m file/var/log and snots. So we're looking for the snot alerts. So the file is called alerts and the snot folder. So when I press enter, I don't see anything. Can you see? I don't see anything. It's empty. But later on, you will start to see something on the screen. So we just leave it running at the screen over here. It's normal. Okay, you don't see anything. It's normal. So let's go over to H5. Okay, remember H5 is running a web server. So we will use H5 to try and download this file called nimda.m, w32nimda.m. Okay, this file is a virus or malware. So obviously, do not run this file on your actual Windows. You will only run it in your VirtualBox or VMware. So to do that, I'll go to my H5. H5. H5 is over here. So let's drag it into the screen. And H5, I'm going to type this command, wget 209.165.202.133 colon, okay, the port 6666. Okay, slash w32.imda.m.exe. So it's a Windows file, okay? It's a Windows exe file. Just try to be careful. For Linux, it's case sensitive, so you should make sure the letters are big when it's big, small when it's small. Okay, so it's case sensitive. So once this is done, press enter, and you will see this on the screen. So this shows that the wget command is executed. It managed to download the file 100%, and the file size is about 337 kilobytes. Very small file. Okay, so the file has been downloaded. So there are some questions you can try to answer. What port is used to communicate with the malware web server? So the port number, can you see from the screen here? What is the port number? The port number is over here. This is the port number 6666. Okay, so this is the port number. Oops. I can't copy, so I just write down here. 6666. Oh, can't see. I don't know why it's not shown. Okay, so was the file completely downloaded? Yes. How you know? Because the file shows 100%. Okay, 100% completely downloaded. Okay, let's go on. Did the IDS generate any alert relating to the file download? Okay, let's check. So how do you know whether the IDS relates any download? So we need to go over to R1, okay, to inspect the payload. So when you go over to R1, remember you have two R1. So this is the first R1, the second R1 is here. So notice that on the second R1, remember just now it was blank, right? Now you will see this message. Malicious server hits. Okay, and a bunch of IP address 209.165.200.235. Okay, so what this has shown is the intrusion detection system called Snort detected the malware, and it will trigger alert that will display on R1, okay, which you will see over here. So this is the alert that was triggered when we tried to download a malware file. Can you see? I tried to download a malware file just now. The download is 100%, but it will trigger this alert. So the Snort intrusion detection system, or IDS, managed to detect the malware inside the incoming traffic and then display an alert on the R1, this alert file. Okay, so let's answer the question over here. What was the source and destination IP address used in the transaction? Okay, the source address is this one. This is your source address. Okay, because it's white color. And then the destination address is, I think it's this one. This is your destination address. Oops. Change it to red color because it's transparent by default. Okay, so this is source, this is destination. How do you know it's source destination? Because of this arrow sign. Can you see? So this arrow sign indicates that this is the source, and then this is the destination. Okay, so let's go on. Based on the alert shown above, what was the source and destination ports? Okay, so now we are looking for ports. Just now we are looking for destination address. So the addresses and ports are same. So for the source port is this number here after the colon 34484. Okay, 344. And then the destination port is this port here 6666. Okay, so this is a source and destination port. Based on the alert shown above, when did the download take place? Timing is over here. This is a timestamp. Okay, so my timestamp is supposed to be here. So I read this one. January 11, 6 o'clock, 29, 18. So just write down lah. 01/11. Oh, it's transparent. So let me change the color. And then what else? The timing is 06. Why I can see? So it's 06:29 minutes. And what's the timing? 18 seconds. 18 seconds. Okay, so this is the timestamp based on the alert we captured just now. Okay, next, based on the alert, what was the message recorded by the IDS? So message is malicious server hits. Okay, so this is the message. Going down here. Okay, so this was the message we captured just now. Malicious server hits. So let's go on. Okay, on H5, we can next use the TCP dump command to capture the event and download the malware if you want. So H5, so let's go over to H5 and we can try to do the TCP dump for this command. So for this case, let me type TCP dump -I for inputs is H5. The port is F Ethernet 0 port. The base -W file. Okay, we want to save the file into this file called pcat file. Okay, so namda.download.pcat. Remember to put the last n, this punctuation mark, this one. So if you leave the n, then what you will see is after you press enter, the prompt will stay here. It will not come back to the original so-called console over here. Okay, so it will stay here. So it will continuously be listening. So this program I'm running now is listening on this port. Okay, H5 and 0 to see all the traffic. So now after that I can press enter a few times to try to get back to the shell. So let me just press enter. Okay, so now I'm back to the shell again. So this program is still running. By the way, it's running on the background. Okay, it's running on the background, but foreground I already come up to the console here. So let's go back to the program. So on this H5 again, we are going to download the malware again, just to trigger the alert. So H5, I'm going to issue the same command, wget 209.165.202.133:6666. Okay, the file name is called /w32.imda.m.exe. Okay, so let's double check before we press the enter. wget 209.165.202.133:6666. And then once we are happy, press enter. So again, the malware will be downloaded and you can verify and see the download is 100% done. So this will go on and we can check the TCP dump program, okay, that we have been running at the background just now. So let's check the TCP dump, which is at where is the TCP dump? H5. Okay, so H5 has the TCP dump because it's at the background. So the TCP dump is still running. It's running at the background. So we can stop the TCP dump, or we can bring the TCP dump program to the foreground. Because it's running in the background, so we can bring it to the foreground with the FG command. FG, press enter. So you can see now the foreground program, which is the TCP dump, is running in the foreground. So it is still running. TCP dump is running over here. So we can stop this program by typing Control C. Okay, so I just type Control C over here, and then it will stop TCP dump. Okay, so I have managed to capture some packets over here. Can you see? 58 packets received by the filter. Okay, it may not be the same as this, doesn't matter. So next, I'll go over to H5 to verify the PCAP file is saved. So I will save this, check the PCAP file list, that L. So notice that now my PCAP file has been captured over here. So this is the PCAP file I just downloaded, save Gen 11. Okay, let's go on. There are some questions they are asking. How can this PCAP file be useful the security analysis? Okay, so what happened is when we have any events that trigger, we can actually monitor the event using TCP dump and then save the file. Why we need to save the PCAP file? Because we want to do post-event analysis. So that's why you can answer something like this. The PCAP file so essentially we can save the PCAP file and then perform any forensic analysis on the malware after that. Okay, so let's take a look at the next part. So we are going to modify the firewall rules so that we can actually change it to trigger based on different IDS alert. So in this lab, R1 is not only running IDS but also running a firewall called IP tables. So we are going to use IP tables to try to configure the firewall. So let's go over to start another R1 section. So we go over to the terminal. So then we type another R1 session, extern R1. So this is a fresh new session on R1 over here. So let's verify our IP table firewalls. Type IP tables dash capital L dash small b. Press enter. So right now you can see the firewall is basically black. There is no rule configured for this R1 firewall. Okay, so what chains are currently in use? The chains are input, forward, and output. Okay. So let's go on. Okay, part C, we are going to use the firewall and define a firewall rule so that whenever there is an event that occur, we will trigger it and display on the screen. So the firewall rule will be something like this. IP tables dash capital I forward. Oops. Okay. Dash small p. It's TCP traffic, TCP ports, and the destination address is 209, 165, 202, and 133. Running out of space. Finally, the destination port is a double dash. Remember, double dash. The ports is 6666. So destination port is not finish it. Dash J drop. So dash J drop. Yeah, it's a rather long command. Okay, so let's double check before we issue the command. IP tables dash cap I forward dash small p TCP dash destination 21965 202.123 dash dash D port destination port 6666, and the last part is dash J drop. Okay, we already press enter. So now the rule has been added to the IP table firewall. Let's check the firewall table again. So we are going to issue the same command, IP tables dash L dash B. So now notice that your firewall has a new rule, which is what you have said just now. The rule applies to the forward, okay, the forward chain. So notice over here. Okay, now let's try to download the malware again. Okay, so we use this command on H5. So H5 is here. So let's try to download the command or the malware. Okay, so this is the command. Okay, let me clear the screen. It's getting a bit crowded. So let me try to download the malware again. So this is the command to download the malware. And when I press enter, this is what you will see. Okay. Previously the server managed to download the malware, but now this is what you will see. It will show connecting to ... So what happens is the server H5 is no longer able to download the malware. Okay, connection failed. Timeout. Okay, so of course you can continue to wait, but we'll just stop here for now. Control C. Okay, so after this, let's try to answer some question. Was the download successful? No, the download wasn't successful. Why is the download failed or not successful? Because we earlier on we define a firewall rule. Okay, we block the firewall not to accept the traffic. Remember just now we said the traffic server, the malware server. So what happens is after I introduce this rule to the firewall, any packet coming from this firewall, from this server, through this port 86666 will be dropped. Okay, so drop means I will remove any packets that come in from this server, this port 6666. That is why my download failed. Okay, of course there will be other ways to manage this access, but we can also block the port alone, or maybe we can set a certain timing to block the port for a period of time, maybe during the office hour and so on. Okay, then more or less conclude this lab for the Snort intrusion detection system and the firewall IP tables.